Hello, welcome to a lesson on tree diagrams. Today I'm going to show you a couple tree diagrams and then we're going to go through a problem dealing with it. Now, a tree diagram, this is a tree diagram for flipping a coin once. So our first action is either heads or tails, and then rolling one die. So our second action is over here, where the die outcomes are 1 through 6, and those span out from each of the outcomes of our first thing, flipping a coin. Now we already did this in the lessons, and when you do this, this top branch, these top two branches represent H1, then H2 and H3 and so on. And since this is equal, like the probability of getting heads or tails is 50-50, or maybe we should say 1/2 and 1/2. And the probability over here, each of these is 1/6. So I could write 1/6. It would look pretty sloppy if I did uh, on each of those because I can't write that small. But those are the probabilities. And to find each of the probabilities, you multiply this branch by the next branch. So 1/2 times 1/6 is 1/12. 1/2 times 1/6, 1/12. So each of these are going to be a 1/12 probability. This one is a slightly more complicated tree diagram where this is of internet users between the age of 18 to 29, 30 to 49, and 50 to 69. And then these probabilities are the proportion of people in those age groups in this particular study. So once we have them split up into these three age groups, now we wanted to check if they're using some online chatting feature. I think this was a few years ago, but the 47% of the younger demographics did, or 53% didn't. And the next age bracket, you can see that the proportion of people using is going down. Now, in order to find the probability, again, you multiply 0.29 times 0.47, you get the probability over here. And so on and so on to find all of the probabilities. Now, this little c here is the complement, which means that this is chat, this is not chatting. Chat, not chat, and so on. Now, there's a few questions that we want to answer about this. We want to find the probability of A1. So that's the probability that they are in the first age group. Spread this out so I can write. The probability they're in the first grade age group is 0.29. And that's it. The probability that they chat, given the fact that they are in age 1. Well, all the people in age 1 are here. So knowing that this is true, the fact that they chat is 0.47. Now, the next two get slightly more complicated. What's the probability that they don't chat? Don't chat are these group of people don't chat, this group of people don't chat, and this group of people do not chat. So if I add up these three numbers, I get up to 0.7482. Now, I'll do this one in red maybe. This says, what's the probability they're in age 1 given the fact that they chat? So chat would be these other numbers. So if I add those up, 0.1363 plus 0.0987 plus 0.0168, I get 0.2518. So that out of all of these people, the people that chat, 0.2518, what's the probability that they're in the first age group? Well, these people aren't, but these people are. So that's 0.1363. Now if I take 0.1363 and divide it, now I can find that this is 0.54-ish, 130 something something. So about 54%. So given the fact that they chat, about 54% of the people in the study that chat are in the first demographic. All right, now we're going to get to an AIDS problem. Now AIDS test. An AIDS test has a probability of 0.004 for giving a false positive. It also has the probability of 0.05 that the test is a false negative. If 7% of the village has AIDS, what is the probability that somebody with a positive AIDS test actually has AIDS? It's a very good question. Uh, there's a lot of question about this because if you get a positive result, that's meaning that the test says you have AIDS, you don't want to tell them unless you feel pretty confident that they actually have AIDS. So let's take a look at this. Now the first thing we want to look at is the amount of people with AIDS in the village. So we can say AIDS, and we can use the same notation with a little c up here, meaning not AIDS. So the probability someone has AIDS in this village is 0.07. The probability they don't have AIDS is 0.93. And we're good there. Now the second thing we're going to test is whether the test was positive or negative. Positive or negative. So it has a um, 0.004 chance for being a false positive. So that means they don't have AIDS, but it says positive. So that's 0.004 chance. Now, if that's a chance there, it's going to be at 0.996, 1 minus that they don't have it, that they get a negative sign given the fact that they don't have AIDS. Now, the false positive is another issue. So, or false negative. So if you have AIDS, but it says you don't, that would be 0.05. And so 95% of the people that have AIDS, the test comes out positive. So then it says, what is the probability that someone has a positive AIDS test with a positive AIDS test actually has AIDS? So we want to find the probability that they actually have AIDS, given the fact that their test is positive. Whew. Important question. So first we have to look at the probability that it is positive. So we go through and multiply these numbers. So 0.93 times 0.004 is 0.00372. And the probability that they get a false positive, 0.07 times 0.95. That's 0.0665. So out of all of the ones that are positive, here and here, what's the probability that they actually have AIDS? Well, the denominator will be these two added together, 0.00372 plus 0.0665. I have 0.07022. Now the probability that they have AIDS and it says positive is 0.0665. Now when we divide these, 0.0665 divided by our answer is 0.947. So that's the answer to our question, about 95% of the time. So if you are in this village and you get a positive AIDS test, you're about 95% sure that you actually have AIDS. So about 1 out of every 20 person gets a positive AIDS test, and they don't actually have AIDS. So something good to keep in mind. All right, now let's see if you can finish the problems.